Haven't scheduled yet. For each graph, we're going to, again, we are actually going to graph it. This one says to just state the characteristics, but we're going to practice all of our graphing skills. So the first thing, step 0, is factoring it, if possible. This one we have a difference of squares on the bottom. We can factor it. Then step 1, looking at our non-permissible values. Do we have any non-permissible values? X can't equal -2. And X can't equal 2. It's nice to write them both separately, right? It's really like 2 more letters. It really doesn't take that long. Okay? These become vertical asymptotes because nothing cancels at x equals 2 and x equals -2. Step 2, we're going to look if this has oblique asymptotes or horizontal asymptotes. Higher degree is on the bottom. So if you look at the highest degree, well, it's the x squared. We have 1x squared on the bottom, no x squareds on the top. That's going to be a horizontal asymptote at y equals 0. So we can draw things in. Y equals 0, x equals -2, and x equals 2. Do we have a y-intercept? Well, a y-intercept is when you plug in 0 for x, and you'd have -4 over -4. So you have the point 0, 1. Do we have any x-intercepts? Yes. The only time you're going to have an x-intercept is when your numerator is equal to 0.
Oh, good morning.
Good morning.
Sorry for interrupting. Could you please have Eve's time card to the office?
So our only x-intercept is at 4. Again, this feels a little weird to have it on an asymptote, but that's okay. Now, because of that being our only x-intercept, in the middle section, we now have enough information to draw it. If I'm drawing it towards this asymptote, am I going to go up or down? I have to go up, because if I went down, I would make another x-intercept. And I already found that my only x-intercept is at 4. Same thing on this side, it needs to go up, because my only x-intercept is at 4. This section to the left of -2, well, I'm going to need more points. So I'm going to plug in -3. I find it easiest to figure out things if I plug things into my factored form. -3 minus 4 is -7. This will be -1, and that'll be -5. That simplifies to -7 over 5. So I have the point -3, -7 over 5. And that's enough to tell us in this section, since there's no more x-intercepts, that this is what our graph is going to have to look like. Now in the section to the right of x equals 2, I have an x-intercept, but I don't know if it's going to be going up towards this asymptote or down towards this asymptote. So I'm going to try and see what happens when I plug in 3. So again, I'll go to my factored part here. I'll erase the work that I have. If I plug in 3, can you see that you get -1 there? You would get 5 there and 1 there. So if I plugged in x equals 3, I'm going to get -1/5. So that tells me this, it's going down towards that asymptote. Bigger than 4. Is it bouncing off of there or is it going above? What's happening? So if I plugged in one more point at 5 and checked what happens when I plug in 5, again, really, it's like an advanced table of values is our method of graphing here. We get our asymptotes to give us some parameters to work with, and then after that, we just use our table of values to find enough points. So when I plug in 5, I'm going to get 1 on the top. And I'm going to get 7 here and 3 here. I'm going to get 1/21. So I get a point that's just barely above. And then after that, it's got to go towards the asymptote. So it just comes above the graph momentarily, and then it tends back towards the asymptote. Yes? No, we can't say for sure that 5/121 is the maximum. We would have to check our values in there. We made it look, because this is naturally for us to want to do that, have that as our maximum. My guess is that the maximum might even occur before 5, like 4.5 or some sort of decimal. But you could use your graphing calculator. At this point, that's all we have to figure that out. You could graph this function and then find the maximum between 4 and 20. Set 4 as your left and set 20 as your right, and see what that maximum would be.
What do you mean when you say it goes like above the asymptote and comes back?
Yeah, so our graph, see, you have to draw a smooth curve through these points. So it's going through those points, but then this asymptote is telling you what's happening when x gets really big. So it's got to go back towards that asymptote. I'm going to leave you to try part B. Again, step 0, factor it completely. Step 1, list your non-permissible values. Step 2, find out if this one has oblique asymptotes or horizontal asymptotes. Draw all of your asymptotes and then go through a table of values. Find your x-intercepts and your y-intercepts and other points until you have enough information to graph it. Questions for practice on number 3 are 6 and 7.